Greetings of peace and prosperity. This is Group 5 and I'm Johal T. Sultan from BS Psychology, and today I will going to discuss about logic. Logic is not easy to summarize in a few paragraphs the subject matter known as logic. For lawyers and judges, logic is the science of correct reasoning. They often use logic to communicate more effectively, construct valid arguments, analyze knowledge of logic to be one of the most important predictors of future success for their new students. Many other professions also make extensive use of logic. For instance, programmers use logic to design computer software. Electrical engineers use logic to design circuits for smartphones. And mathematicians use logic to solve problems and construct mathematical proofs. Logic statement and quantifiers. Gottfried Wilhelm Leibniz was the first mathematician to study symbolic logic, aiming to convert it from a philosophical subject to a formal mathematical discipline. However, he never fully achieved this goal. Mathematicians like Augustus de Morgan and George Boole contribute to the advancement of symbolic logic as a mathematical discipline. Boole's work and investigation of the laws of thought is considered the discovery of pure mathematics. Logic statements. Every language contains different types of sentences, such as statements, questions, and commands. For instance, is the test today? Is the test today? Is a questions. As long as mayroong question mark, ito siya ay pangungusap na patanong. Next is go get the newspaper. Is a command. Kung baka may inutusan ka na tao, so kunin yung newspaper sa command. So yun. This is nice jacket is an opinion kasi hindi naman lahat ng jacket is maganda. Kumbaga para sa akin ay pangat, so para sa'yo is maganda. So sinasabi mo na this is a nice jacket. Last is, Manila is the capital of the Philippines. So, it's a statement of fact kasi totoo naman, ang capital ng Philippines is Manila. A statement. A statement is a declarative sentence that is either true or false, but not both true and false. It may not be necessary to determine whether a sentence is true to determine whether it is a statement. For instance, consider the following sentence. Yosemite National Park is located in California. You may not know if the sentence is true, but you do know that sentence is either true or it is a false, and that it is not both true and false. Thus, you know that the sentence is a statement. Example 1. Identify statement. Determine whether each sentence is a statement. A. Florida is a state in the United States. B. How are you? C. X plus 1 equals 5. A solution of letter A. Florida is one of the 50 states in the United States. So this sentence is true and it is a statement. B. The sentence how are you is a question. It is not a declarative sentence, thus it is not statement. C. X plus 1 equals 5 is a statement. It is known as an often given value of x. It's true or false, but not both. Simple statements and compound statements. A simple statement is a statement that conveys a single idea. A compound statement is a statement that conveys two or more ideas. Connecting simple statement with words and phrase such as and or if, then, and if, and only if creates a compound statement. For instance, I will attend the meeting or I will go to school. It's a compound statement. It is a composed of the two simple statements. I will attend the meeting and I will go to school. The word or is a connective for the two simple statements. And guys, the simple statement is itong itong I will attend the meeting. Pag sinumpayan na siya ng or yung kumbaga dinugtungan na siya ng sample like I will attend the meeting or I will go to school, yan na yung compound statement. Example 2, write the negation of a statement. Letter A. Ellie Goulding is an opera singer. B. The dog does not need to be fed. A solution of letter A. Ellie Goulding is not an opera singer. Kumbaga guys is yung ang negation guys is kumbaga binabaliktad mo yung sentence guys. Kumbaga dito pa sa letter A na Ellie Goulding is an opera singer. So binaliktad ko siya guys. Kumbaga ginegation ko siya guys. Magiging Ellie Goulding is not an opera singer. So yun siya guys. Solution letter B, the dog need to be fed. So yun siya guys sa first guys, the dog does not need to be fed. So ginegate natin siya guys is magiging the dog need to be fed. George Bull used symbols such as P, Q, R, and S to represent simple statements and the symbols of, ito siya guys yung symbol guys, yung pabaliktad na V and V na symbol and tilde na symbol and yung arrow and yung dalawang arrow na symbol to represent connectives. So ito yung table guys. Ang not, symbolic niya is itong tilde na symbol. Itong end naman, ang symbol niya is yung pabaliktad na V. Itong or naman, ang symbolic niya is itong para siyang B talaga mismo V. And itong if din naman guys, ang symbolic niya is yung arrow na isa lang. And ito namang F and only if, ang symbolic niya is itong dalawang arrow guys. So tandaan nyo lang siya gan guys. Question: what connective is used in a conjunction? True value in true tables. The true value of a simple statement is either true or false. The true value of a compound statement depends on the true value of its simple statements and its connectives. A true table is a table that shows the true value of a compound statement for all possible true values of its simple statements. The negation of the statement, today is Friday, is the statement, today is not Friday. In symbolic logic, the tilde symbol is used to denote the negation of a statement. If a statement P is true, its negation tilde P is false. And if a statement P is false, its negation tilde P is true. See table at the left. The negation of a statement is the original statement. Thus, tilde parenthesis tilde P parenthesis can replace by P in any statement. Example 3. Write compound statements in symbolic form. Consider the following simple statements. P is stand for today is Friday. Q, it stand for it is raining. R stand for I am going to a movie. S stand for I am not going to the basketball game. Write the following compound statements in symbolic form. A, today is Friday and it is raining. B, it is not raining and I'm going to a movie. C, I am going to the basketball game or I am going to a movie. D, if it is raining, then I am not going to the basketball game. Solution of letter A, P, ito siya guys, nakita nyo naman tong sa gilid guys, solution niya. So, P is stand for today is Friday. So, ayun siya. Itong symbolic na parang pabaliktad na V is yan yung end. And itong Q stand for it is raining. So, yan siya guys yung solution. P and symbolic V and yung Q. Kasi today is Friday and it is raining. Solution B. So, dito siya guys sa ano naman, solution B. Kasi yung sa statement is it is not raining. So, may not siya. So, yung Q na stand for it is raining. So, ginigate natin siya guys. So, gilagyan natin siya ng symbolic form na tilde. So, yun. Tilde Q and symbolic na and. Ayun siya. And yung R is stand for I am going to a movie. So, naging ito siya guys, yung solution. So, it is not raining and I am going to a movie. Mali na naman siguro yung pag-explain ko. So, letter C, ganun pa rin siya guys, yung naging negate pa rin siya. So, S is stand for I am not going to the basketball game. So, itong sa consider the following statements guys is naka-negate na siya guys. Kumbaga, meron siyang not dito. So, dito naman sa write the following compound statements. So, I am going to the basketball game. yung ano niya guys, yung statements niya guys. So ginawa natin siyang not, kumbaga gibaliktad natin siya guys. So yun, I am going, S is stand for I am not going to the basketball game. So ayun siya. And yung symbolic na form na B, ayun siya guys, or yun siya guys, yung symbolic na V, yan yung or. And R is stand for I am going to a movie. So yun, I am going to a movie. So naging kalabasan niya guys is I am not going to the basketball game or I am going to a movie. Letter D, solution of D is ito siya guys sa gilid. So Q is stand for it is raining. And meron siyang arrow guys. So yan yung if and then. Ito siya guys. So tingnan mo sa D guys. Itong sa the right following compound statements sa symbolic form. Itong sa D. If, yung arrow na symbol guys, yung sa D, itong sa solution, yan yung F, tsaka itong then. So, yung F is kailangan sa first. So, if it is raining. So, yun siya. Then, yung D ng so solutions, S stand for I am not going to the basketball game. So, ayun siya guys. Then, I am not going to the basketball game. So, yan yung solution guys. Example 4. Translate symbolic statements. Consider the following statements. So, dito naman guys, yung symbolic form is gawin natin siyang statements. Kumbaga, i-transform natin siya guys. Yan. P stand for the game will be played in Atlanta. Q stand for the game will be shown on CBS. R stand for the game will not be shown on ESPN yung. S stand for the Mets are favored to win. Write each the following symbolic statements in words. So letter A. So Q is stand for the game will be shown on CBS. So ayun sa solution guys. A, ayan siya on CBS. Tapos may symbolic siya na yung pabaliktad na V. So yun siya yung end. Tapos yung P stand for the game will be played in Atlanta. So naging kalabasan guys is the game will be shown on CBS and the game will be played in Atlanta. So, ganun lang siya kadali guys. Madali rin siyang intindihin. So D, ito siya guys. Meron siyang symbolic na tilde. So, mangyari dyan is yung R stand for the game will not be shown on ESPN. So, the game will be shown. So, mabaliktad siya guys. Yung manigit natin siya guys. Kumbaga, dito siya is not. Magiging, the game will be shown on ESPN. And may arrows may symbolic siya na guys, yung pabaliktad na V. So, ito siya guys, yung end. And S stand for the Mets are favored to win. So, ayun siya guys. The Mets are favored to win. So, yung kalabasan, the game will be shown on ESPN and the Mets are favored to win. And letter C, solution of the letter C is the Mets are favored to win if and only if the will not be played in Atlanta. So, S stand for the Mets are favored to win. So, ayun siya guys. The Mets are favored to win. And itong symbolic guys na parang double arrow guys, yan yung if and only if. Yan siya guys, yung symbolic. Itong symbolic na ganyan itong double na arrow guys. Ito siya guys, yung if and only if. So, may negate dito sa guys, may symbolic form na tilde sa P. So, P is stand for the game will be played in Atlanta. So, meron man siyang symbolic form na tilde guys. So, magiging will not be played in Atlanta. So, naging not siya guys. So, kalabasan guys is the Mets are favored to win if and only if the will not be played in Atlanta. Compound statements and grouping symbols. If a compound statement is written in symbolic form, then parentheses are used to indicate which simple statements are grouped together. Table 5.2 illustrates the use of parentheses and parentheses to indicate groupings for some statements in symbolic form. So, ito siya guys, yung table 5.2. Tingnan nyo siya guys. Symbolic form is P, and yung symbolic na and siya yan guys, yung symbolic na pabaliktad na V, and yan, and parenthesis Q, and yung symbolic na V guys is yan yung R. And yung symbolic na yung kasunod niya is tilde, yan yung not, and R, tapos parenthesis. The parenthesis indicate that Q and tilde are grouped together. So, ito daw siya guys, itong sa may nasa parenthesis, yan siyang magkagrupo guys. Yung ginamining niya. And sa next naman na symbolic form, parenthesis P, and symbolic na pabaliktad na V, Q, parenthesis. Yan naman siya yung grouped guys. Kumbaga grouped yan sila na statements siguro o ganun. Tapos symbolic na R, tapos symbolic na V, tapos R. So the parenthesis indicate, tignan siya guys sa parenthesis indicate. P and Q are grouped together. So yun siya guys. Yung nasa parenthesis, sa loob ng parenthesis guys. The next is parenthesis, tingnan lang siya guys. Same lang pa rin guys. So dito naman sa baba guys, parenthesis P, symbolic V na pa baliktad, and tilde, Q, parenthesis, and arrow, tapos may parenthesis na naman, and R, and symbolic V, tapos S, and parenthesis. So P and symbolic tilde Q are grouped together. R and S are also grouped together. Basta may nasa loob lang siya ng parenthesis guys is grouped ko na siya yun guys. So, if a compound statement is written as an English sentence, then a comma is used to indicate which simple statement are grouped together. Statements on the same side of a comma are grouped together. See table 5.3. So, ito siya guys. English sentence, P, tapos comma, and Q or not R. So, the comma indicates that Q and symbolic form ng tilde R, tapos are grouped together because they are both on the same side of the comma. Oh, yun, tama guys. Ang group naman dito guys is yung Q. Pag may sa comma naman guys yan, kumbaga pag P tapos comma, so ang group naman din guys is itong Q at saka itong R. So, next is P and Q. So, ganun pa rin guys. Pag may comma din naman dyan is kumbaga yung group na naman guys, itong si P and Q na naman. Tingnan mo ito. P and Q are grouped together because they are both on the same side of the comma. Tapos ito namang if P and not Q, then R or S. So, P and symbolic form ng tilde and Q are grouped together because they are both to the left of the comma. Yun naman siya guys. Itong si FP tapos not Q. Siya yung magkagrupo guys. Kasi sa gilid siya ng comma. And R and S are grouped together because they are both to the right of the comma. So, magkagrupo din yung guys, yung R tsaka S. Next is, if a statement in symbolic form is written as an English sentence, then the simple statements that appear together in parentheses in the symbolic form will all be on the same side of the comma that appears in the English sentence. Example 5. Translate compound statements. Let P, Q, and R represent the following. P stand for you get a promotion. Q, you will complete the training. R, you will receive a bonus. The question niya guys is, write parenthesis P and symbolic V na pabaliktad, tapos Q and parenthesis, and symbolic na yung arrow, tapos R as an English sentence. So, and sa letter B naman, write if you do not complete the training, then you will not get a promotion and you will not receive a bonus in symbolic form. So, itong sa B guys is, itong sulat na natin siya guys in a symbolic form. Solution, letter A. Tignan nyo siya, ano guys, yung picture guys. Yan siya guys, yung sa solution ng letter A. So, sa A kasi mayroon siya guys, if, meron siyang if. Meron siyang ifs. So, magiging ganun siya guys, yung ano niya, symbolic niya. In English sentence. Ito siya guys yung solution. Because the P and the Q statements both appear in a parenthesis in the symbolic form, they are placed to the left of the comma in the English sentence. If you get a promotion, ito siya guys, yung P, makita nyo naman sa ano, sa picture, itong ano niya. And ito siya yung ano guys, if, and then, ito yung symbolic na yung arrow guys, yung arrow. So, yan siya guys. Tapos Q, you stand for, you complete the training. So, tingnan nyo sa na guys, yung, sa example 5, balik nyo guys. Yung stand is, Q stand for, you complete the training. So, ito siya guys, you complete the training. In parenthesis, so, may comma siya guys, tama naman, yung sa parenthesis may comma siya, dapat doon. So, yun. Then, so, yung arrow guys is yan yung if and then. So, normal siya pang tatlo. R stand for you will receive a bonus. Thus, the translation is, if you get a promotion and complete the training, then you will receive a bonus. Solution, letter B. So, di ba doon guys, sa letter B is, kumbaga, yung statement is isulat natin in a symbolic form. So, B, letter B, because not P and the not R statements are both the right of the comma in the English sentence, they are grouped together in parentheses in the symbolic form. So, ito siya guys, yung ano niya. If you do not complete the training, comma, then you will not get a promotion and you will not receive a bonus. So, ito siyang yung symbolic form niya guys. Symbolic tilde, Q, and yung arrow, tapos parenthesis, and symbolic form ng tilde, P, and symbolic na V, tapos symbolic na tilde, R, and parenthesis. Thus, the translation is, yun siya guys, ito siya guys, yung solution. Next is, the use of parenthesis in a symbolic statement may affect the meaning of the statement. For instance, symbolic form tilde, parenthesis P, and symbolic V, Q, parenthesis, indicates the negation of the compound statement, P, V, Q. The statement, symbolic tilde, parenthesis P, and symbolic V, Q, and parenthesis, is read as, it is not true that P or Q, the statement, symbolic tilde P, and symbolic V, Q, if you order cake and ice cream in a restaurant, the waiter will bring both cake and ice cream. In general, the conjunction P and symbolic V na pabaliktad, tapos Q, is true if both P and Q are true. And the conjunction is false if either P or Q is a false. The true table at the left shows the four possible cases that arise when we form a conjunction of two statements. So, ito siya guys yung true table for P and symbolic V na pabaliktad tapos Q. Ito siya guys. Tignan nyo lang. So, true value of a conjunction, the conjunction P and symbolic form ng V pabaliktad, tapos Q is true if and only if both P and Q are true. Sometimes the word but is used in place of the connective and, for instance, I ride my bike to school, but I ride the bus to work. Is equivalent to the conjunction, I ride my bike to school and I ride the bus to work. And in this conjunction, P and symbolic V, Q is a true if P is true, or Q is true, or both P and Q are true. The truth table at the left shows that this conjunction P or Q is false if both P and Q are false. However, it is true in all other cases. True value of this conjunction, the conjunction P and symbolic V, Q is true if and only if P is true. Q is true, or both P and Q are true. Example 6. Determine the true value of statement. Letter A, 7 greater than 5. B, 5 is a whole number and 5 is an even number. C, 2 is a prime number and 2 is an even number. A solution of letter A, 7 greater than 5 means 7 greater 5 or 7 equals 5. Because 7 greater than 5 is a true. The statement 7 greater than 5 is a true statement. And letter B, solution of letter B, this is a false statement because 5 is not an even number. Letter C, solution of letter C, this is a true statement because each simple statement is true. Quantifiers and negation. In a statement, the word some and the phrase there exists and at least one are called existential quantifiers. Existential quantifiers are used as prefixes to assert the existence of something. In a statement, the words none, no, all, and every are called universal quantifiers. The universal quantifiers none and no deny the existence of something, whereas the universal quantifiers all and every are used to assert that every element of a given set satisfies some condition. Recall that the negation of a false statement is a true statement and the negation of a true statement is a false statement. It is important to remember this fact when forming the negation of a quantified statement. For instance, what is the negation of the false statement, all dogs are men? You may think that the negation is no dogs are men, but this is also a false statement. Thus, the statement no dogs are men is not the negation of all dogs are men. The negation of all dogs are men, which is a false statement, is in fact some dogs are not men, which is a true statement. The statement some dogs are men, the statement some dogs are not men can also be stated as at least one dog is not men, or there exists a dog this is not men. What is the negation of the false statement? No doctors write in a legible manner. Whatever the nation is, we know it is must be a true statement. The negation cannot be all doctors write in a legible manner, because this is also a false statement. The negation is some doctors write in a legible manner. This can also be stated as there exists at least one doctor who writes in a legible manner. Table 5.4a illustrates how to write the negation of some quantified statements. So, ito siya guys. Tignan nyo yung guys. Table 5.4a, quantified statement and their negations. All x are y, and negation niya is some x are not y. No x are y, negation, some x are y, some x are not y, and all x are y. Some x are y, no x are y. In table 5.4a, the negations of the statements in the first column are shown in the second column. Also, the negation of the statements in the second column are the statements in the first column. Thus, the information in table 5.4a can be shown more compactly as in table 5.4b. So, ito siya ang 5.4b. Quantified statement and their negation display in a compact format. So, yun siya guys. All x are y, negation some x are not y. No x are y, negation some x are y. Example 7, write the negation of a quantified statement. So, letter A, some airports are open. B, all movies are worth the price of admission. C, no odd number are divisible by 2. Solution of letter A, no airports are open. And solution number B, some movies are not worth the price of admission. And solution of letter C, some odd numbers are divisible by 2. So, yan siya guys, yung negation of quantified statement. The next topic is truth tables, equivalent statements, and tautologies.
Good morning everyone, this is Norlin Silongan. Today we will be discussing about truth tables, equivalent statements, and tautologies. Expressing rules of logic in words for elaborate compound statements can be cumbersome. By adopting symbols, the work of evaluating all forms of compound statements can be greatly simplified. Our previously accepted rules for the truth value of each type compound statement as well as of the negation of statement can now be conveniently expressed in a compact form known as truth table. Truth table is the table that shows the truth value of a compound statement for all possible truth value of its simple statement. It shows how the truth or falsity of a compound statement depends on the truth or falsity of the simple statement from which it's constructed. So we'll start by looking at truth tables for the 5 logical connectives. Sa table na makikita nyo ay ang summary ng statement, connective symbolic form, and type of statement na pag-uusapan natin sa topic na ito. For instance, on the first part, makikita nyo ang statement na not P. Not is a connective, and yung P ang magsisilbing statement or variable. Then, ang symbolic form naman nito ay tilde P, or it can be read as not P. At ang type of statement naman ito ay negation. Sa second part naman ay ang statement na P and Q at ang connective nila ay ang symbol na and. Ang symbolic form naman nito ay caret or and, kung saan mababasa natin ang P and Q. In such table, T designates that the statement is true and F that it is false. And here are the 5 examples of truth tables incorporating the definitions of negation, conjunction, disjunction, and for the conditional and biconditional, it will be discussed by my colleague a few moments later. Let's start with the negation. The negation of the statement is the original statement. Sa negation, ang tandaan lang natin, pag gumawa tayo ng statement na true, pwede natin siyang gawing negation kapag dinagdagan natin ang statement ng word na not. Ang keyword lang natin ay not. Like for example, Selena Gomez is a singer. Pwede natin siyang gawing negation pag ginawa natin siyang Selena Gomez is not a singer. In terms of conjunction statement, P and Q, which asserts that P and Q are both true, then the output will be true. Ang ibig sabihin sa conjunction naman, kapag ang statement sa P at Q ay true, ang magiging output nito ay true. Maliban na doon ay false na ang sagot. Ang keyword naman dito para malaman na conjunction ang statement ay ang word na and. Notice that the wedge symbol looks vaguely like the letter N in and.
For example, let P represents the statement Rihanna likes ice cream, and let Q represents the statement she eats chocolate. In conjunction, the answer here is P and Q, or Rihanna likes ice cream and she eats chocolates.
So disjunction P or Q is a statement which asserts that either P is true or Q is true or both both are true, the output would be true. If all statement is false, the output is false. Sa disjunction naman, kapag ang P or Q ay false statement, understood na false na rin ang output. Maliban na doon ay true na ang output. Ang keyword sa disjunction ay ang salitang or. Notice that this is the inclusive sense of the word or. Also, the V symbol looks vaguely like the letter R in or.
For example, let P represents the statement Lady Gaga sings the poker face, and let Q represents the statement Madonna will not go to the concert. In this junction, the answer here will be P or Q, or Lady Gaga sings the poker face, or Madonna will not go to concert.
Pagdating naman sa conditional and biconditional, it will be discussed by the next reporter. Now let's proceed to the equivalent statement. Two statements are equivalent if they both have the same truth value for all possible truth values of their single statement. The notation P is equivalent to Q is used to indicate that the statement P and Q are equivalent. Let's have a sample here. Let's show that not P or not Q and not P and Q are equivalent statements. First thing that we do here is to get the truth value of first statement. Let's start with the value of P and the value of Q. The negation of Q and the P or not Q after we get the value of the first statement. Let's proceed to the next statement. That is the not P. And Q, which is shown on the second to the right table. As we observe, the answer in the first statement is equivalent to the final answer on the second statement,
which is false, false, true, false. Therefore, we conclude that statement 1 is equivalent to statement 2, since as you can see on the second red line table on the middle table denotes identical answer.
A statement which is always true is called a tautology. A statement which is always false is called a contradiction. One way to determine if a statement is tautology is to make its true table and see if it's always true. Similarly, you can determine if a statement is a contradiction by making its truth table and seeing if it is always false. For example, shows that P or Q and not P or Q is a tautology. Let's assume that P statement represented by 4 columns true, true, false, false, and Q as true, false, true, false. The not P of P statement are false, false, true, true. When you wanted to get the answer to the not P or Q, follow the rules of disjunction, which is kapag false lahat ng statement, false na rin ang output. As you can see on the right side table above, please pause and analyze when you have time. Then we get the answer true, false, true, true. In the next statement, watch the table P and statement not P or Q and follow the disjunction rule to get the answer. And that results to true, 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 true. Remember that the basic logic of tautology is that all statement is always true. Then all our answer are true. Therefore, it's tautology. And that ends my presentation. If you have questions, clarification, and other concerns related to the topic, please feel free to ask me or PM me if you still have a confusion. And thank you and have a great day. Bye for now.
Good day, everyone. My name is Nomia Kesedik, and I will be reporting the conditional and biconditional. Conditional statements can be written in FP then Q form or in FPQ form. For instance, all of the following are conditional statements. For example, if we order pizza, then we can have it delivered. Next is if you go to the movie, you will not be able to meet us for dinner. In any conditional statement represented by if P then Q or if P Q, the P statement is called the antecedent and the Q is called the consequent. Identify the antecedent and the consequent of a conditional. Number 1 question is, if our school was this nice, I would go there more than once a week. So the antecedent is our school was this nice. We remove the if because we are finding the antecedent and the consequent. Then our consequent here is I would go there more than a week. Then next is if you don't get in that plane, you'll regret it. The antecedent is you don't get in that plane, and the consequent is you'll regret it. Next is arrow notation. The conditional statement if P then Q can be written using arrow notation, which read as P implies Q. Truth table of the conditional P implies Q. The conditional P implies Q is false if P is true and Q is false. For example, if 3 is greater than 3, then 2 plus 7 is equals 4. It is wrong because the Q form is false. Next is an equivalent form of the conditional P implies Q. P implies Q similar to not P or Q. We are finding here is the not P or Q. So, number 1 question is, if I could play the guitar, I would join the band. Then the P here is I could play the guitar. We change it to not P, which is I cannot play the guitar. Then add the or, then I would join the band. Next is if Cam Newton cannot play, then his team will lose. Not P or Q. Cam Newton can play, then add the or, then his team will lose. The negation of P implies Q. The formula is not P implies Q similar to P and not Q. So write the negation of a conditional statements. Number 1 question is, if they pay me the money, I will sign the contract. So we are focusing here the P and not Q, which is the P, we put the they paid me the money, and we put the N, and I will sign the contract, not Q, which is the not Q. We reverse it to I did not sign the contract. So number 2 question is, if the lines are parallel, then they do not intersect. So we put the lines are parallel because the P here is the lines are parallel. Then put the N, then they do not intersect, which is the not Q. We reverse it to they intersect. Next is the biconditional statement. Biconditional statement, P implies Q and Q implies P is called a biconditional and is denoted by P and only if Q. Conditional P and only if Q. The formula is P and only if Q is similar to P implies Q and Q implies P. Let P, Q, and R represent the following. So the given here is P, she will go on a vacation. Q, she cannot take the rain. R, she cannot get a loan. Write the symbolic biconditional statements in Word. So the symbolic biconditional statements are A, P, if and only if not Q. Letter B, not R, P, if and only if not P. So we should write this P, which is she will go on vacation. If and only if not Q, which is she cannot take the rain, we change it to she can take the rain. Letter B, which is the not R, if and only if not P. So the R here is she cannot get a loan. We should change it to not R, which is she can get a loan. If and only if not P, which is that she will go on a vacation, we change it to she does not go on vacation. So that's all, guys. Thank you for listening.
Good day, I am Shahana J. Siraji and I will be discussing the conditional and the related statements. So, the conditional statements are fundamental concepts in logic and mathematics. They express relationships between conditions and outcomes. A conditional statement, often denoted as P implies Q, consists of an antecedent and a consequent. These statements take the form if P then Q, where P and Q are statements. For example, if it rains, then I will bring an umbrella. Every conditional statement can be stated in many equivalent forms, and it's not always necessary to state the antecedent before the consequent. So here are several common forms used to express the conditional statements. Here are an examples. Write each of the following in if P then Q form. Sa statement A muna tayo. So kung titingnan natin dito sa table na to, ang statement A is nasa form siya ng Q provided that P. Ang P natin is divisible by 2 and the Q is the number is an even number. So to transform this into if P then Q form, we simply switch the position of P and the Q. So ang magiging sagot niya is if it is divisible by 2, then the number is an even number. The statement B. So ang statement dito is today is Friday only if yesterday was Thursday. So kung titignan natin dito sa table na to, itong statement B is nasa form siya ng P only if Q. Ang P natin is today is Friday and the Q is yesterday was Thursday. So to transform this into if P then Q form, we switch the positions of the P and Q. So ang magiging sagot natin, if today is Friday, then yesterday was Thursday. So in both statements, we rearrange the statements to fit the if P then Q form by identifying the antecedent and the consequent appropriately based on the given conditions. Now let's talk about the converse, the inverse, and the contrapositive. Every conditional statement has three related statements. They are called the converse, the inverse, and the contrapositive. So first, let's talk about the converse of a conditional statement. The converse is formed by simply flipping the positions of the antecedent and the consequent. So here is an example. If it rains, then the ground is wet. Ang antecedent natin dito, it rains. Ang consequent naman is, the ground is wet. So, ang magiging converse ng conditional statement na to ay, if the ground is wet, then it rains. Next, we have the inverse of a conditional statement. The inverse is formed by negating both the antecedent and keeping the consequent the same. Here is an example. If it's not sunny, then I'll bring an umbrella. So, ang inverse ng conditional statement na ito ay, if it's not sunny, then I'll bring an umbrella. Lastly, we have the contrapositive of a conditional statement. The contrapositive is formed by negating both the antecedent and the consequent, and like the converse, switching their positions. So here is an example. If I didn't study, then I won't pass. So ang contrapositive ng conditional statement na ito ay, if I won't pass, then I didn't study. Here is another example. Write the converse, inverse, and the contrapositive of a conditional. So, ang conditional statement natin is, if I get the job, then I will rent the apartment. Ang converse nito ay, if I rent the apartment, then I get the job. Ang inverse naman, if I do not get the job, then I will not rent the apartment. And lastly, the contrapositive. If I do not rent the apartment, then I did not get the job. Now let's talk about their relationships using truth tables. Looking at truth tables, we can see that the original conditional and the contrapositive are logically equivalent, and that the converse and the inverse are logically equivalent. So the key points to understand this are the conditional statement and its contrapositive have the same truth values. If one is true and the other is true, and if one is false, the other is false. The converse and the inverse have the same truth values, but they are not necessarily the same as the truth values of the original conditional statement. In other words, if the original is true, it doesn't mean the converse or the inverse are true, and vice versa. Let's proceed to the given examples. Determine whether the given statements are equivalent. So sa statement A muna tayo. If it's raining, then the ground is wet. If the ground is wet, then it's raining. The solution here is the second statement is the converse of the first. The statements are not equivalent. So here is the explanation on the solution of the statement A. So the first statement says that if it's raining, then the ground is wet. This is generally true. The second statement says that if the ground is wet, then it's raining. This is not always true because the ground can be wet for reasons other than the rain, like someone spilling water. So in statement A, the two statements are not equivalent because the converse is not always true. Let's proceed to the statement B. If a person is eligible to vote, then they are at least 18 years old. If a person is not at least 18 years old, then they are not eligible to vote. The solution is the second statement is the contrapositive of the first. The statements are equivalent. Now let's understand why these statements are equivalent. The first statement tells us that if someone can vote, they must be at least 18 years old. This is a general rule. The second statement, which is the contrapositive of the first statement, states that if someone is not at least 18 years old, they cannot vote. This also makes logical sense. The statement B are equivalent because they both express the same idea. In mathematics, it is often necessary to prove statements that are in if P then Q form. If a proof cannot be readily produced, mathematicians often try to prove the contrapositive if not Q then not P, because a conditional and its contrapositive are equivalent statements. A proof of either statement also establishes the proof of the other statement. Here is a situation. A mathematician wishes to prove the following statement about the integer x. So the first statement is, if an x squared is an odd integer, then x is an odd integer. If the mathematician is able to prove the statement if x is an even integer, then x squared is an even integer. Does this also prove the statement 1? Yes, because the second statement is the contrapositive of the first statement. Example, use the contrapositive to determine a truth value. Write the contrapositive of each statement and use the contrapositive to determine whether the original statement is true or false. A. If A plus B is not divisible by 5, then A and B are not both divisible by 5. Statement B. If x cubed is an odd integer, then x is an odd integer. Statement C. If a geometric figure is not a rectangle, then it is not a square. Solution of the given statement. A. If A and B are both divisible by 5, then A plus B is divisible by 5. This is a true statement, so the original statement is also true. Statement B. If x is an even integer, then x cubed is an even integer. This is a true statement, so the original statement is also true. Statement C. If a geometric figure is a square, then it is a rectangle. This is a true statement, so the original statement is also true. So that's all. Thank you.
Good day, everyone. I am Alfaide Singh and I'll be presenting the continuation of Miss Siraji's report. So together, let's learn about Grace Hopper. So who was Grace Hopper? Grace was born Grace Brewster Murray in New York City in 1906 to Walter Fletcher Murray and Mary Campbell Van Horn. As a child, she attended private schools and generally lived an upper-class lifestyle. She earned undergraduate degrees in mathematics and physics from Vassar in 1928, where she graduated Pi Beta Kappa. After Vassar, Hopper began attending Yale, her father's alma mater, for graduate school. There, she studied under Howard Engstrom, a pioneer in computers. She earned a master's degree in mathematics in 1930, and then she returned to Yale and her studies there. She graduated with a PhD in mathematical physics in 1934. And while working on her PhD, she also taught classes at Vassar. She became an associate professor there and stayed until she joined the Navy in 1943 and began her work with computers. So Grace Hopper has a lot of contribution to the invention of the informational age today. Grace Murray Hopper was a computer pioneer who helped to make computers more user-friendly. She created various tools that aided in the simplification of coding and the language that computers know about. Her work with the US Navy during World War II and Vietnam was critical in the development of technology as we know it today. Standards she established for the Navy in the 1970s are still in use today and are officially recognized by the National Institute of Standards and Technology. So, although her first work with computers was with the Navy, her work in the commercial sector was actually one of the most groundbreaking, and she had a lot of accomplishment during her time. In 1952, Hopper's team developed the first compiler called AO. Essentially, the compiler translated mathematical code to binary code. This meant that eventually one program could be written for multiple computers. And then Hopper's next big achievement was Flowmatic. It was the first programming language to use regular English words. In teaching computers to understand basic English, Hopper helped to make them and their language more accessible and user-friendly. In 1959, Hopper took this push toward user-friendliness a step further by inventing COBOL, or Common Business Language. While many people work on this project, Hopper was the one working hard to promote it both in the military and the private sectors. This new language led to the development of COBOL compilers during the 1960s and continued to grow in widespread usage through the 1970s. So lastly, this one I have been thinking of a lot in the past because I have been curious why we call computer bugs. Aren't you curious too? So it was said that back then when she was assigned to a project at Harvard with the Navy, while working in a research lab in the post-war years, one of the computers began to repeatedly malfunction. When the researchers took it apart, they found a moth inside. Hopper then stated that the computer had to be debugged, and thus, the term still used today for computer problems was coined. So I guess that will be all for Miss Grace Hopper, and here's some quotation from her that piqued my interest. And now, proceeding to our next topic, we will be discussing about NAND, also known as the Sheffer stroke. It is a connective in logic equivalent to the composition NOT AND that yields true if any condition is false and false if all conditions are true. So on the upper right side, you can see the illustration of the NAND gate, while on the lower left side is the truth table for NAND. That will be all for this topic. I hope that you learned something in this discussion, and thank you for listening.
Good morning, everyone. I am Baymon Shanga. So today I will discuss the symbolic arguments. Arguments. In this section, we considered methods of analyzing arguments to determine whether they are valid or invalid. An argument and a valid argument. An argument consists of a set of statements called premises and another statement called the conclusion. An argument is valid if the conclusion is true whenever all the premises are assumed to be true. An argument is valid if it's not a valid argument. In the argument about Aristotle, the two premises and the conclusion are shown below. It is customary to place a horizontal line between the premises and the conclusion. First premise, if Aristotle was human, then Aristotle was mortal. Second premise, Aristotle was human. So the conclusions, therefore, Aristotle was mortal. Arguments can be written in symbolic form. For instance, if you let H represent the statement Aristotle was human and M represent the statement Aristotle was mortal, then the argument can be expressed as first premise H represent the statement Aristotle was human, then M represent the statement Aristotle was mortal. Second premise H Aristotle was human. Conclusion. Therefore, M Aristotle was mortal. So our conclusion is Aristotle was mortal. The three dots are symbol for therefore. Example, write an argument in symbolic form. Write the following argument in symbolic form. The fish is fresh, or I will not order it. The fish is fresh, therefore I will order it. So the solution, let F represent the statement, the fish is fresh. Let O represent statement, I will order it. The symbolic form of the argument is first premise, F, then O. The F represent the fish is fresh. Then O represent the statement, I will order it. The second premise is F. The fish is fresh. Conclusion, therefore, O, I will order it. That is our conclusion. The symbol V is often used to represent the logical disjunction, which means that at least one of the two statements connected with V must be true.
Good day everyone, I am Arabella Silvano, and today we will talk about the continuation of the topic symbolic arguments, which is the arguments and truth tables. In a symbolic arguments, an argument consists of a set of statements called premises and another statement called the conclusion. An argument is valid if the conclusion is true whenever all the premises are assumed to be true. An argument is invalid if it is not a valid argument. So, paano natin masasabi ng isang argument ay valid or invalid? Dito napapasok ang tinatawag nating truth table. The following truth table procedure can be used to determine whether an argument is valid or invalid. Truth table procedure to determine the validity of an argument. Number 1, write the argument in symbolic form. So, ang pinakauna nating gagawin ay i-translate o in-convert ang ating argument statement in symbolic form. Number 2, construct a truth table that shows the truth value of each premise and the truth value of the conclusion for all combinations of truth values of simple statements. So, number 2 natin, ang laman ng truth table ay truth value of each premise and conclusion. Now, yun yung purpose ng symbolic form. Kaya tayo gagawa ng symbolic form dahil yun ang isusulat natin sa ating truth table na nakadepende kung ilang premise meron sa isang argument statement. Kadalasan kasi dalawa lang ang meron or pinaka-common. Pero meron ding iba na 3 or 4 ang premise. And then ang pinakahuli ay ang column ng conclusion. So after nating gumawa ng truth table, tsaka lagyan ng truth value yung premises natin at tsaka yung conclusion, yung panghuli naman ay i-identify natin kung yung statement ba mismo ay valid or invalid. Next is number 3. If the conclusion is true in every row of the truth table in which all the premises are true, the argument is valid. If the conclusion is false in every row in which all the premises are true, the argument is invalid. So meaning, ang premises ang pagbabasehan natin para ma-determine kung anong number of rows ang kasali sa identification natin, kung valid ba or invalid. So first things first, we will identify kung anong row yung may premises na lahat ay true. Tapos kung lahat ng premises na yun ay true, and then yung conclusion niya din ay true, then meaning valid yung statement. Now kung yung premises naman ng isang argument statement ay true lahat, and then yung conclusion niya ay false, then the argument statement is considered to be invalid. We will now use the truth table procedure to determine the validity of the argument of Aristotle. So we have the example number 1, which is the statement Aristotle was human and Aristotle was mortal. So ang pinakauna natin gagawin kung susundin natin ang procedure to make a truth table to determine the validity of the argument is we will write the argument statement into its symbolic form. So, we will let H to represent the statement Aristotle was human and M to represent the statement Aristotle was mortal. Kung i-convert natin siya into its symbolic form, we have H, if then, which is the arrow symbol, and M. For its, yun yung ating first premise. And we have the second premise, which is the letter H that represent the statement Aristotle was human. And for the conclusion, therefore, we have the letter M, which represent the statement Aristotle was mortal. So kung mapapansin nyo, yung doon sa row ng conclusion, meron kang makikita na 3 dot, yung katabi ng letter M, which means siya yung symbolic form ng conclusion or the word therefore in a statement. And a reminder, please pakitandaan po kung saan po natin ilalagay ang ating symbolic form in a pagkasunod-sunod na order, which is ang ating first premise. Sunod nito sa baba nun ay ang second premise at ang panghuli sa baba ay ang ating conclusion. So now, ang susunod natin gagawin is gagawa na tayo ng sarili nating truth table or we will construct a truth table for the validity of our argument. So makikita nyo sa ating table, we have 4 columns. First column is ito yung ni-represent na yung ating symbolic form argument, which is letter H and M. The second column, we have the first premise, which is the symbolic form H and the if-then arrow and M. Next is yung third column na kung saan doon nakasulat ang second premise and its symbolic form na letter H. And then yung panghuli is yung fourth column na kung saan nakasulat doon ang kanyang conclusion. And then yung symbolic form na letter M. Now, nagawa na natin i-construct ang ating argument statement into a symbolic form. So, paano yan kung ilalagay na natin yan siya sa ating truth table? So, let's consider kung ilang klaseng statement or statement meron tayo. So, we have letter H at si letter M. So, meron tayong dalawang statement. So, yun yung ilalagay natin sa first column. Si letter H at si letter M. So, after natin ilagay si H at M, ilalagay na natin yung automatic na truth value for statement, which is true, true, false, false for letter H, and sa letter M naman ay true, false, true, false. Automatic na ganito ang pag-label for the truth value per statement kasi depende yan or nakadepende kung ilang ilang kasing statement tayo meron sa per statement natin. So, dito, meron tayong dalawa. So, we only have 4 rows. So, ang formula is 2 raised to n equals to 2 raised to 2 equals to 4, which is yung 4 rows natin. So, since meron na tayong symbolic form, then na-label na natin yung H and M and the rest ng premise and conclusion. Let's find the truth value of each premise and the conclusion. So, ganito, sa column ng H and M, may value sila na both true and true. Ang conditional statement or ang magiging truth value ng first premise ay true. Next naman ay yung sunod na row, kasunod na row ng row 1, which is meron silang value na true at saka false. This one ay false ang kanyang statement kasi itong hypothesis H, kahit na true yan siya, nagbe-base kasi tayo kapag sa conditional statement sa conclusion, yung letter M, na yung conclusion natin ay false. Then the rest of the statement will be considered as false, kaya false to siya dito. So, dito naman tayo sa row number 3, which is mapapansin nyo is baliktad. Ang hypothesis naman ay ang false, pero yung conclusion naman ay true. So, ang answer or ang conditional statement dito ay true pa rin, kahit false pa yung hypothesis kasi sa conclusion tayo nagbe-base which is yung letter M. Now, last naman is yung sa row number 4, which is false, false. This is considered to be true. True yan kasi ang statement, kumbaga false din yung hypothesis, therefore magiging false din yung conclusion. Sa ganito kasing klaseng statement, isa lang talaga yung magiging false. Yung ganitong katulad ng ganitong situation yung sa row number 2, kapag true ang hypothesis and then false ang conclusion, ang kakalabasan niya is magiging false siya. Ngayon, tapos na nating lagyan ng truth value ang first premise. Sunod naman ay ang second premise, which is yung letter H. Ang gagawin lang natin is you just need to copy the truth value ng hypothesis natin or the letter H, which is the true, true, false, false value. And for our conclusion, which is the letter M, you just need to copy the truth value of the conclusion or the letter M, which is true, false, true, false. And now, papunta pa lang tayo sa exciting part. Tapos na nating lagyan ng truth value ang lahat ng ating premises and also the conclusion. Now, ang gagawin na lang natin is to identify which row in all premise is valid or invalid. As you can see, I already crossed out the row number 2 hanggang row number 4. Why? Diba sa argument validity or validity of the argument, first things first na kino-consider natin ay yung premise. Yung mga premises na kasali sa statement. Diba we have the first and second statement? Now, titingnan natin kung alin ba or kung saan sa mga row na to kung ano yung dalawang premises na may dalawang truth value na true. Makikita nyo sa table na I already crossed out the remaining rows at ang natira na lang ay si row number 1 because si row number 1 lang ang may dalawang truth value na true for the first and second premise, and the rest is true nga yung sa first premise niya pero false naman ang kanyang nasa second premise and vice versa. So therefore, row number 1 is the only row in which all the premises are true. Because the conclusion is true in row number 1, the argument is valid. So that's all for my report and thank you for listening.